Afghanistan, 1984. A Soviet column is taking fire from a ridgeline. The BTR-80s fan out, return fire, and the order comes to dismount. Troops push open the small side hatches near the rear wheels, crawl through on their hands and knees, and drop onto the road. Some make it, some don't. Not because of enemy fire, because of their own vehicle's rear wheels, still spinning. The BTR-80 was not killed by the enemy that day. It was killed by its own exit. In a minute, I'll show you the exact design choice Soviet engineers made to fix that, and why the solution also quietly introduced a new trade-off they never fully resolved. This is the story of the BTR-80, built to fix the one flaw that made the BTR-80 deadly to its own crew, and why it became the backbone of Soviet and post-Soviet motorized infantry for the next 4 decades. Before you understand the BTR-80, you have to understand what made the BTR-80 a nightmare to exit under fire. The BTR-80 was an 8-wheeled armored personnel carrier introduced in the early 1960s. It could carry up to 14 troops depending on the variant, swim rivers, and keep pace with tanks. On paper, it looked like a capable vehicle. In practice, getting out of it in a combat situation was something close to a death sentence. The exit hatches sat low on the hull, just ahead of the rear axles. To get out, a soldier had to open a small hatch, lower himself out feet first, and drop to the ground, all while the vehicle's rear wheels were right there. If the driver didn't stop or the vehicle rolled even slightly, the consequences were catastrophic. Soviet after-action reports from early conflicts documented cases of soldiers being run over by their own transport. That was problem 1. Problem 2 was the engine. The BTR-80 used not one engine, but 2. Twin KamAZ 49B, gasoline engines, each driving a separate side of the drivetrain. The logic made sense on a drafting table. Redundancy, no single point of failure. In the field, it was a maintenance nightmare. The 2 engines had to be tuned in sync, or the vehicle pulled to one side. They required different throttle inputs. Spare parts had to cover 2 entire powertrains. And gasoline, unlike diesel, is a fire risk. A penetrating round near the engine bay could turn a personnel carrier into a burning trap. So Soviet engineers had 2 clear mandates going into the BTR-80 program. Fix the exit. Fix the engine. Neither one was simple. Here's the part most people miss. Redesigning an exit hatch is not just a matter of moving a door. It affects armor coverage, internal troop capacity, vehicle weight, and center of gravity. Move the hatch too high and troops exit while fully exposed. Keep it low and you recreate the original problem. Make it bigger and you weaken the hull. They needed survivable crew egress, structural hull integrity, and usable internal space. Most designs compromise one of those. The BTR-80 had to find all 3. The engine problem carried its own constraints. A single engine had to produce enough torque to move a 13.6-ton vehicle at speed, through water and rough terrain, without the redundancy fallback of a second power plant. And it had to fit in roughly the same space as 2 smaller ones. The BTR-80 entered production in 1984 and reached Soviet units in 1986. The engineers made 2 decisions that defined everything else. First, the engine. The twin-gas setup was replaced by a single KamAZ 7403 turbocharged diesel. 260 horsepower, 1 drivetrain. Diesel fuel burns far less readily than gasoline under ballistic impact, which matters enormously when troops are sitting meters from the fuel and engine compartment. Maintenance dropped sharply because crews now dealt with 1 engine, 1 timing system, 1 throttle. And the torque curve on the KamAZ actually improved off-road performance compared to the twin-gas setup. Second, the hatch. This is where the design looks counterintuitive, but it isn't. The BTR-80 introduced a combined hatch system on each side of the hull. The upper portion swings up and outward, acting as a shield above the opening. The lower portion drops down, creating a step. A soldier opens both, stands in the aperture, and can actually return fire from behind the raised upper panel before fully dismounting. When they do drop out, they land on the step, and the wheels are behind them. The geometry of the exit changed completely. The trade-off was that the hatches were still toward the rear of the troop compartment, meaning the first man out still had to push past the others. Dismounting under fire was faster and safer than the BTR-60, but it was never fast. That tension never fully went away. The armament also received an upgrade. The KPVT 14.5mm heavy machine gun remained the main weapon, but the mounting gave it better elevation range, which mattered for the terrain Soviet forces were operating in by the mid-1980s. Before the BTR-80, dismounting from an APC in contact meant choosing between staying inside a vehicle that couldn't maneuver effectively in tight terrain, or crawling out a low hatch while your own wheels threatened to finish what the enemy started. After the BTR-80, a squad could stop, swing open both panels of the side hatch, use the raised upper door as immediate cover, and put fire on a threat before their boots touched the ground. That is not a minor upgrade. That is a fundamental change in how infantry interacts with its transport at the moment of highest danger. Soviet and later Russian troops used this in Afghanistan's valleys and later in Chechnya's streets, where dismounting under observation was not optional. The BTR-80 made that survivable in ways the BTR-60 simply did not. If you like these engineering breakdowns, subscribe. Now let's look at where the BTR-80 dominated and where the design still got exposed. The BTR-80 is not designed to fight tanks. It is designed to protect infantry on the way to a fight and give them a base of fire when they get there. The KPVT 14.5mm can deal with light vehicles, low-flying aircraft, and fortified positions. The PKT 7.6 2mm coaxial handles dismounted infantry. Between those two systems and the vehicle's mobility, a BTR-80 section can suppress a position while its dismounts move into it. The key to the system's logic is that the vehicle and its crew are meant to work as one unit, not as a taxi and its passengers. The BTR-80 keeps moving, keeps firing, and the dismounts work within that pattern. The improved hatch is what makes that integration possible. Troops can re-enter the vehicle faster, mount under fire, and reposition. The vehicle is not just transport. It is a mobile weapons platform that its infantry operates around. Volume of fire matters here for the same reason it always matters in suppression. You don't need a perfect shot if you put enough rounds through a threat's decision cycle to break it. It was a genuine improvement over the BTR-60, but it carried a quiet penalty. The BTR-80 is still a wheeled, lightly armored vehicle. In Chechnya in 1994 and 1995, Russian columns operating BTR-80s in Grozny found out what happens when an APC designed for open terrain meets urban combat, RPGs, and upper floor fire positions. The improved hatch that protected troops from wheel strikes did very little against a rocket-propelled grenade fired from 3 stories up at a 45-degree angle into the hull roof. The vehicle's protection philosophy was calibrated to a European land war. Move fast, disperse, don't let terrain trap you. The moment you put it in a city where movement is channeled and every window is a firing position, the thin welded steel hull became a liability. Grozny made that brutally clear. The engine improvement was real. The hatch improvement was real as well. But the BTR-80 was still a 1960s design philosophy dressed in a 1980s package. The fundamental trade-off between protection and mobility was never resolved, because it can't be, not in this class of vehicle. Western APCs of the same era, like the M113 and its successors, made different trade-offs. American and NATO doctrine leaned toward more protection at the cost of some amphibious capability and off-road performance. Soviet doctrine went the other direction. Build something that can cross a river, keep pace with tanks, and be produced in the hundreds of thousands. Simpler, cheaper, more numerous. The BTR philosophy wins on logistics and numbers. The Western philosophy wins when the threat is a well-equipped opponent with anti-armor capability. Neither is wrong. They reflect what each side expected the next war to look like. BTR-80s are still in active service in over 20 countries as of the mid-2020s. They have shown up in Ukraine, in African conflicts, and in Central Asian operations. The reason is not that they are the best APC available. The reason is that they exist in large numbers, their parts are well understood, and they still perform the core task: move infantry, protect them from small arms, give them a platform to fight from. The modern battlefield has added drones to the equation, which the BTR-80 was never designed to face. But the hatch design still matters. The ability to dismount quickly and use the vehicle as cover is the same capability it was in 1986. The threat is different. The geometry is the same. That's why the BTR-80 wasn't just an APC. It was a lesson in what good enough actually means in military engineering. Not perfect, not the safest, not the most capable, but survivable in the ways that matter most to the soldier climbing out of it. Back to that Afghan road. The BTR-80 didn't make dismounting safe. Nothing does. But it gave the soldier a door that opened upward into cover, a step to land on, and a wheel that was finally, reliably behind them. That's not a small thing. In those seconds between vehicle and ground, it was everything. So here's a question worth thinking about. If you were designing the next generation of APC today, knowing what drones and loitering munitions can do, what would you change first? The armor, the mobility, or the exit? Leave your answer in the comments.